Hello everyone, welcome back to another episode of Math Unlocked with your host, Mrs. Rhodes-Grierson. What are we doing today? Today we're writing the equation of a line given 2 points on the line. Now I have the points A and B that are lying on the same straight line, and we want to know what then is the equation of this line. Now, the equation of the line that we're writing in the form is that we want to write the equation of the line in slope-intercept form. And that form is the form y equals mx plus c. So what I'm going to do is that if given that an equation should be written in the form y equals mx plus c, I first need to ensure that I know what are the variables being represented here and what do they stand for. Now, your y and your x would have been very familiar to you. X is your input, y is your output. On a coordinate, your first number represents your x value, your second number represents your y. So within the points A and B, I would have x and y on both points. Now, m represents the gradient or the slope of the line, while c is representing your y-intercept. We also call C your constant because it is in this equation, it's the only number that stands without a variable attached, right? So if I want to write an equation in this format, it therefore means that I must know the value of M and I must know the value of C, because I need to insert number values for these two variables that I'm now looking at. These two letters are real numbers representing real values of what is happening with the line that A and B lies on. Now, the gradient of the line is represented by what is the ratio of the rise compared to the run of that line. And when we're doing the gradient of a line, we can compare any 2 points on the line. But given that these are the 2 points that we know, these are the points that we must use. Now let's analyze what does this rise and run mean. On your Cartesian plane, your rise is represented on your y-axis, while your run is represented on your x-axis. So we're looking at how far up or down are we going based on where we started, and the run is looking at how far across are we going based on where we started. So bearing in mind that we started at point A, and what's the location of point A? So we're placing point A on the Cartesian plane. Here is point A. It's at 1, 4. Now let's look at where would we go given that this is the position of point B. Point B is at 3 units on the x. If A is at 1 unit on the x, it would mean I'm going right to get to B, and I'm going how many units? Since I'm at 1, I'd be going 2 units across. 1, 2. This means that I would have passed the number 2 and end up at the number 3. I'm not remaining here because B is at 3, 8, which means I need to go up since y is positive. I was at 4 units on the y-axis. I was at 4, so I'm going to be going up 4 more units to get me to 8. So I'm traveling 1, 2, 3, 4 more units up. If you were on a Cartesian plane, and I'm not on the plane now using a graph sheet, but just figuring out how this movement would have looked based on the coordinates that I'm given. So based on the fact that I'm saying that A is at 1, 4, and I want to get to the point B, which is at 3, 8, I know from where A is, I would have moved 2 units to my right to get from 1 to 3, and from 4 to 8, I would have had to go 4 units north, and that means B would have been someplace up there. So let's go. So how far is B from A? Horizontally, which is my run, B would have been 2 units across, and that's to my right. How far is B from A vertically? It would have been 4 units up. So that means my rise would have been 4 units and my run would have been 2 units. B is located at 3, 8. Now, another thing that we could look at is the fact that if I started at 1 on the x and ended at 3, it means therefore that the distance between them is the difference between them, and the difference means to subtract. So where does the statement of x2 minus x1 comes from? These are my x coordinates. So I'm going to call this x1, which is my starting point, and I'm going to call that x2, which is my ending point. Now if I take the difference of the two, which is 3 minus 1, it therefore means that I would have traveled a journey of 2 units. For my rise, I'm going to take the difference of the two again, because I started out at 4 and I ended at 8. The difference between the two numbers is 8 minus 4, which would have given me 4 units. So to obtain the rise and the run, it means that once I know 2 points on a line, the difference in the y values would have been y2 minus y1 divided by the difference in the x values, which would have been x2 minus x1. What are the values that we just checked out? We just ended up that the rise is 4 and the run was 2. Simplifying that, it means that my gradient is 2. So this is how I would obtain the first value that I'm looking for. My gradient is 2. Now the second value that I'm looking for is the c value, which is my y-intercept. How do I obtain where is it that the line intersects the y-axis at? All right, let's go. So we're looking to see where does the line intersect the y-axis. All right, guys, so let's finish up the equation of the line. So now I found the gradient of the line, and I need to know what then is the c value. What's the y-intercept? Note that I'm not actually looking at the line. I don't know where the line is now, because all I know is that I've used these points to obtain the gradient. Bearing in mind we're not drawing the line on the Cartesian plane, so we are not seeing exactly where it cuts through the y-axis. So I'm going to rely on my algebra skills to assist me in finding the value of c. Now how do I do that? In this equation, I know that c is the constant. In order to solve an equation for an unknown, it means that I would therefore need to know all the other variables. Now, what we know is that x and y represents a coordinate on the line, a point that is on the line. We have more than one point on the line. Seeing that the x and y represents any point that is on the line, I could use any of these points to represent the x and y value. So if I choose A, it means that for the point A, x is 1 when y is 4. So utilizing this information, I'm going to substitute the values in order to obtain what is the value of c, given that these 2 points are on the same line that c is on. So y is 4, we already found m to be 2, m multiplies x, x is 1. The only unknown in the statement now is the value c. So what we're going to do is that we're going to simplify and transpose to find c. So we're going to make c the subject of the statement by subtracting 2 from both sides, because I want to eliminate the 2 from here to see what therefore is the value of c by itself. This cancels this. 4 minus 2 is 2. It therefore means that the value of c is 2. I have now obtained the 2 values I was looking for. Seeing that, I can now write the equation of the line that point A and B are lying on. What's therefore is the equation? The equation of the line would be y is equal to 2 times x plus 2. Note that when I'm writing the equation of the line, I inserted the gradient and the y-intercept. This tells me how steep the line is, and this tells me where does the line intersect the y-axis. I do not put any particular values of x and y, because x and y has multiple values depending on what point you are on the line. But as long as they're on the line, they can be represented in the statement. The equation itself, however, requires just that I insert the values of m and the values of c. Once I would have found those, I can insert them and write what is the equation of the line that would have the points A and B lying on that line. Thank you for watching. Come again, more videos to come.